Hello, friends. This is welcome to this pre-recorded video. Pre-recorded video on the topic generalized technique on of harmonic elimination. This is the topic from unit number one and sorry, unit number two. We are done with unit number one comprehensively, as all of you know, and we are done with unit number two also. Most of the topics are covered regarding inverters, converters, PWM, right? I have given my level best to inputs from the unit number two also, but few topics are still remaining. So I thought that before going for other units, I should go for this one, few easy remaining topics, right? So that one of the topic is harmonic eliminations. I hope after going through this pre-recorded video at your pace later on, with your pace, you will understand this particular topic quite comprehensively. You will understand it better. I will try my level best to explain this topic. So now, without wasting time, I will start with my presentation. Okay, so I am sharing my screen, and I hope it is available. You are in position to see this screen, right? And yes, I'll start with my presentation. So, we are in unit number two, and we are discussing one of the topics left from unit number two, and then definitely we'll go for other units. So, generalized technique of harmonic elimination, and it is also known as selective harmonic elimination. Now, just to get into the topic, right. I think as we were dealing with the unit number one, that is controllers, then comparison of HVDC with the facts, and then relative importance of controllable parameters, two machine systems, all those things we have studied recently, and then again we are going back to the harmonic elimination, harmonics, output voltage, the harmonics present in output voltage, output current of the inverter switchings, all those things we are going back. So I think I should say some few things about this. So my dear friends, no need to go into all details and all nitty-gritties of unit number two, inverters and converters and IGBTs and switchings of IGBTs, 180 degree, 120 degree, all those things are right now not needed. My aim is to this topic. So we are just going to understand one of the generalized technique, one of the popular technique. This technique is based on mathematics. You are just miss one introduction of Fourier, uh, one part of Fourier transform, Fourier series, and that should be known to you. Just it is just a preliminary knowledge of that thing is known to you, and I hope all of you know that. I know that all of you know that. So this is one of the popular technique. I'll just concentrate on this technique in today's pre-recorded video, and to make it simplify only. And we know there is one more name, that is selective harmonic elimination. So I have already explained that this technique is somewhat dependent on um, Fourier ट्रांसफॉर्म Fourier सीरीज, थोड़ा सा उसका नॉलेज भी होना जरूरी है इसके लिए, right? And then yes, selective harmonic elimination, the name itself says that this is another name to the same technique. This is the name also says that we can select the um, harmonic which we want to eliminate. Say, we know 50 hertz, we call it as a fundamental, and then we also know because of that symmetrical pattern, half wave symmetry, full wave symmetry, you know. So, basically, my target is not to go into details. So, because of that symmetry, even order harmonics are also eliminated in most of the waveforms, right? And you also know if we go for three phase waveforms, right? Then tripling harmonics are also eliminated in most of the time, right? Uh, so then fundamentally is 50 hertz. Even order means second order harmonics, then third harmonics, then fourth harmonics are not there. So we are going to target fifth harmonics, right? Fifth harmonics, seventh harmonics, and ninth harmonics. And you also know that this is information from me that lower order harmonics are, they are having more magnitude than the higher order harmonics. Means harmonic number 49, harmonic number 49 will have negligible magnitude, and it will have negligible impact on our uh, total harmonic distortion, or wave quality of the quality of the power we are getting, we are receiving, we are transmitting, right? Then the seventh, fifth, or ninth, these lower order harmonics, we call it as a lower order harmonics. So lower order harmonics, they are having more magnitude. So if I have given a choice, given as a choice, I will definitely go for reduction, elimination of lower order harmonics. So this is so we are at the end, we are students, and we are going for university exams also. So I thought that this is worth to mention that this question appeared in 2019. Discuss in detail generalized technique of harmonic elimination in VSC. VS means voltage source converter, right? So this is one of the, this is the kind of question that is asked in examination, during examination, right? So just for example, I have written that it is appeared in summer 19, it is repeatedly asked, right? So I'm starting with this technique. I'll read first the one effective way to have freedom of controlling voltage and also eliminating lower order harmonics is a method pioneered by Patel and Hoft in early 1970s. एक ऐसा method है which also give two way, it works two way, two benefits are there. We can control voltage, we can eliminate lower order harmonics. Now, now lower order harmonics means we are concentrating on lower order harmonics. And my dear friends, this method will give you means limited freedom, that you can select two, three, four, five. We have to select before applying this method. How many hormones you want to remove, you want to eliminate from the voltage waveform or current waveform, in that case, any waveform. So first of all, you have to decide how many waveforms, and accordingly you have to go for the coding or programming, right? So if you want to remove three harmonics, then you have to decide which three harmonics, fifth order, seventh order, ninth order, like that, or 13, 15, 19, any order you can decide. But obviously it is odd harmonics. And then you apply this, then this particular technique will remove only those three harmonics, only one harmonic, only two harmonics which are pre-decided, right? The concept is simple. You have to decide first how many number of harmonics, and then which harmonic, and then according to our coding program, that harmonics will be reduced. How I'm going to explain it. So first concept is this: you have to decide. Then is there any limitation ki how many harmonics, indefinite, infinite harmonics can I remove? No, 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 no. This is a mathematical technique, and it becomes more complex. We if we increase number of harmonics. So if we keep it in limit, that two, three, four, at the most four or five, then it's okay. Five is also big number for this method, and right. So number of harmonics is limited. Number of harmonics you want to limit it is limited, but don't get disheartened by that, because we are going to target lower order harmonics. So major portion of distortion, major harmonics, we are, these are distorting our waveform. That portion will be eliminated. So most of the 90% of our work is done there, our waveform quality of waveform will be improved. There is no issue on that. So this is that is why it is generalized and it is popular. And one of the Indian only, it is the Indian author, I have deliberately given this name because this is mentioned in our book also, Hingur Ani's book also, Patel and Hoft. And this is not done yesterday or day before yesterday, it is done in 1970s. That means problem of harmonics was identified in 1970s also, 60s. And they have taken that problem seriously, and that's why they have come up with some idea, some method in 1970s only, right? So H.S. Patel and R.G. Hoft, they have presented this method in IEEE transactions, very good reputed transaction it is, of industrial applications. And they have come up with the two parts of that paper. um, Generalized technique of harmonic elimination and voltage control, part 1 and part 2. Part 1 is harmonic elimination, part 2 is voltage control, right? So right now we are interested in both. So you must be now you must have aware become aware that um, these two basic papers are there. From these two basic papers, this basic method, generalized method is taken, that is added to your syllabus. And this must be the first time that these two papers, means you got feel you're in final year, you're studying elective paper, so somewhat advanced subject you are learning. And now somewhere the references are related with the IEEE transactions. Till now, what you used to refer? You used to refer textbooks, then reference books, then sometimes uh, some basic journals. Those are available in library. So now, first time you are referring these papers, so don't worry, we are not exactly referring these papers, and very important part we are going to refer, not completely and thoroughly. So okay, so this is the idea, basic idea behind the behind uh, हार्मोनिक एलिमिनेशन टेक्निक हम क्या कर रहे हैं, व्हाट वी आर डूइंग गोइंग टू डू. I'll show you one diagram and then I'll come back to this particular slide again, right? I am going to have that diagram first, right? This one is, I think, yeah, this one. This is the diagram, right? I was interested in. Okay, so what you are observing? You are observing voltage output waveform, phase voltage, be it phase voltage or line voltage. That is not clear right now. That is not we are not, I'm not interested to classify it into phase voltage waveform or line voltage waveform or single phase voltage waveform, whatever. Um, this is a output waveform, DC, and this is not a continuous square waveform. You must be knowing this. This is not continuous square waveform. Continuous means this is chopped one, means there are number of pulses. This is pulse one, then this is major pulse, then again smaller pulse, again smaller pulse, and then it will be repeated. The pattern will be repeated. So these pulses are formed by I have explained it by having some sinusoidal waveform as a reference waveform, then mixing it with the triangular waveform, and then we call it as a SPWM technique. And by using I hope you have gone through previous pre-recorded videos on SPWM technique. I have given that example with the MATLAB. So MATLAB, with the help of MATLAB, I have explained it. So just again revising it for your interest. So this how these pulses are created. These pulses are created by PWM technique and specifically by SPWM technique, so that we can have less number of harmonics in our voltage. Now uh, we can have some liberty of creating these pulses. Means this is angle alpha 1, alpha 2, alpha 3. So there are three angles. This dark circle contains the value alpha 1, alpha 2, and alpha 3. These are the angles. So this is our angle alpha 1, this is our angle alpha 2, this is our angle alpha 3. So at those particular angles. So this is 180 degree. If we take it as a 180 degree, this is till this point it is 180. This is 360. Sorry, this is 360. This is 180. This is 90. So we have to select the degree, angle in degrees or in radians, and then at those particular points just create pulse. If it is possible for us, if we can control in that way, then we are going to control the harmonics, eliminate the harmonics. So first primary target is to identify alpha 1, alpha 2, and alpha 3, and accordingly chop the waveform, chop the square waveform which is available. Square waveform, you are aware. Right now I don't have any figure to show you square waveform. Waveform, you are always aware. This is square waveform but in pulses. PWM type of waveform is available with us, right? It is PWM type of waveform, and pulses are there of different widths, right? This width is decided by, again, the widths are associated with angles. And my dear students, this is the crux of the matter, and these angles play important role. That means at particular, if we select particular angle, then we can say that third harmonic is eliminated. If we select particular angle, then we can say, like, say that fifth harmonic is eliminated. If we select particular angles, then we can say that seventh harmonic eliminated. This is mathematically proved. We can select three angles also to eliminate three harmonics, that third, fifth, and seventh, like that, or fifth, seventh, or ninth harmonic. We can select angles and those harmonics are eliminated. Magic. And this magic is supported by our mathematics, and that mathematics is somewhere related with Fourier series, Fourier transform, or Fourier series, fundamental of Fourier series. You are at least that basic equations you must know. I'll explain those equations also in this particular pre-recorded video. So I hope now I have explained you the basic soul crux of the matter. I have explained you. So we know that we get AC output, but in square waveform, and square waveform contains lot of harmonics. Sinusoidal waveform contains zero harmonics, and we always try to make our shape of our output voltage waveform, current waveform, like a sinusoidal waveform. If it is possible, then it's okay. Otherwise, we are having number of methods to remove harmonics. Those are present in the output waveform, and one of the method is this one, selective harmonic elimination. We are going to decide angles by at those angles we are going to chop. Now the word chop you must understand, or the word notch. There are so many notches. There are so many notches in the diagram shown, voltage waveform shown, or chops. There are, we have chopped that particular waveform here, and we have removed the harmonics from the that particular waveform. Now this second diagram will give you more idea. So I have again said that alpha 1, alpha 2, alpha 3, alpha 4, alpha 5. Five angles are there. So we are removing, say, for example, this is given 5th, 7th, 11th, 13th, and 7th harmonics are removed. If we chop our waveform in this way, I think this particular wave diagram must have given you more insight about it. So this is our output voltage, AC voltage waveform, and we have created pulses, and by selecting angles we have chopped our square waveform output, AC output, in this way. And if we test this particular AC waveform, then we will definitely, if we go for the harmonic analysis for this waveform, we will find that these harmonics are eliminated. So harmonic eliminations are related with the angles, and angles, how angles are. Now the question is how these angles we get, and the basic is related with the Fourier series. I will take you to that particular point also. If this particular point is understood by you properly, then our lecture is over. Then our lecture is over. This concept is over. Only few points are there remaining. I'll go through those few points, and this our lecture is over. My means motto for taking this lecture is that only: understand the concept, my dear friends, first. So our AC waveform, output AC waveform is not a sinusoidal waveform. Sinusoidal waveform is AC waveform is available through alternators, and this kind of waveforms are available through power electronics devices like inverters or converters. So this is our AC waveform. It is in the form of square waveform, and square waveform contains lot of harmonics. So we that particular square waveform in this way. We select some angles, that alpha 1 to alpha 5, and if we go for chopping of this particular waveform in this format by selecting the angles, then we test for it, then you will find that this particular harmonics are eliminated from the waveform, and our waveform will have very low harmonics, very less distortion that is created by harmonics. Harmonics का जो भी impact होगा, whatever impact is there of the harmonics, it will be reduced to quite extent, almost 90-95% it is reduced. So this is magical method. This is magic. This is concept you must understand. Now, I said that if you understood this concept properly, then my point is over. Right. So remaining points are only in the descriptive in nature. I will take these points once again. Unit number two, topic, question, then these two basic papers. Now I'll go. It involves this. I'll read it out for your understanding. It involves varying specific notches, chops. You also refer to as chops in the square wave, such that specific harmonics are eliminated from the waveform. Right. Now it is explained in detail that one of the degrees of freedom, with m number of chops, there are m number of degrees of freedom, m number of chops, right? कितने number of chops आप चाहते हो, 2 3 4 5 6 10, उतने हार्मोनिक्स रिमूव होंगे. ये सिंपल कंसेप्ट है. एंड वन ऑफ द डिग्रीज ऑफ फ्रीडम fundamental, leaving other m minus 1 degrees of freedom to eliminate m minus 1 harmonics. Means फंडामेंटल को हम काउंट नहीं करेंगे, उसमें फंडामेंटल 50 हर्ट्ज का होगा. m माइनस वन हार्मोनिक्स, अगर हम मान लो 5 डिग्रीज लेते हैं तो 4 हार्मोनिक्स हमारे रिमूव होंगे. m माइनस वन चॉप्स जितने हैं उतने हार्मोनिक्स रिमूव होंगे. दैट सिंपल कंसेप्ट है. फंडामेंटल को छोड़ देते हैं, और m नंबर ऑफ चिप्स चॉप्स हम करेंगे तो m माइनस वन नंबर ऑफ हार्मोनिक्स हमारे रिमूव होंगे. सिंपल पीडीएम कन्वर्टर शोन. और ये जो है स्पेसिफिकली ट्रायंगुलर वेव के साथ. नाउ दिस इज द थिंग, ट्रायंगुलर वेव that is called as carrier wave, and sinusoidal waves that is called as reference wave. PWM is created, right? Frequency is given here. uh, Basically frequency is, I think, ninth times the fundamental. That's why you get um, 5 chops here and 5 chops there. I think four chops you got. M minus one, that is okay, right? Okay, and इसका फॉर्मूला क्या है? K n plus minus K2, right? K1, it is written here, first point. Minus K2. What is K1? Frequency of the multiplier. Frequency multiplier वो 9 नंबर है for this waveform. Just this is introduction type, information type, basic information type. For the figure shown, right? This is 450. What is multiplier? 450 is the frequency of, is the frequency of the reference waveform. Reference मतलब हमारा sinusoidal, ट्रायंगुलर मतलब कैरियर. तो ट्रायंगुलर का फ्रीक्वेंसी कितना है भाई? 450. साइनसॉइडल का फ्रीक्वेंसी कितना है? कितना है? 50. तो K1 is 9 plus minus n वो प्लस माइनस k2 है, n है, n n k2 क्या है, k2 may be taken up to 2, right? And in this way we can go. This is basic information. Other information is that triple harmonics like third nines are already eliminated if we use three-phase bridge circuit. That is also discussed earlier. And okay, so here frequency multiplier is 9. So fifth, 7, 11, 13, these harmonics are um, there, except even order harmonics and triple harmonics are eliminated, right? So here the words are used as 6 pulse, 12 pulse, 48 plus, 24 pulse. So my dear friends, this pulse, 6 pulse, 12 plus, this is not discussed with you earlier. So don't pay much attention here because that will distract you. That will be covered in next lecture, pre-recorded one only. Okay, so this is the information about PWM and basic information. But coming back to our main topic, so you just go through this. This presentation is available for you on your Genome site. This is the extra information required to understand this topic. But basic topic we understood properly, right? And symmetry is involved, angles are involved, harmonic eliminations are involved. M minus 1, that is the formula. M number of chops, we give M minus 1, harmonics eliminated. Or chops means one chop is created, of course, with the help of two angles. So those many angles are there. Now it is somewhat research level topic, how the angles are decided and all those things. So for as you are in UG level, just to for your level, it is sufficient to know that these angles are somewhat related with the Fourier series explanation, Fourier series comparison analysis of the waveform. Right. Again, this there are some words 24 pulse, 12 pulse. These are not covered right now. So I will explain this 12 pulse, 24 pulse, 48 pulse converters concept. Very simple concept it is, right? But right now it is not covered, so don't pay much attention. But go through it, just read it. This is available at your Genome website. And finally, it is explained alpha 1, alpha 2, m minus 1, m plus 1, right? And just okay, I was interested to show you this side. This is what Fourier waveform, Fourier series explanation. F of omega t, function of omega t is equal to summation n is equal to 1 to alpha. Alpha is important. Then a n sin omega t, n omega t plus b n cos n omega t. And with if we have half wave and quarter wave symmetry, now half wave symmetry, quarter wave symmetry, the word symmetry must be knowing quite well. Once you understand the word symmetry, then very easy to understand what is half wave symmetry, what is quarter wave symmetry, right? Then bn equal to 0. If this symmetry is there, then bn will be always equal to 0, and n value of n will be like this: 4 by n pi in the bracket 1 plus 2 summation of k is equal to 1 to m minus 1 to the power k cos n alpha k. ये इक्वेशन का बेस है. ये जस्ट फॉर योर information is there. Right now it is difficult for to understand ये how angles are created. इसके लिए MATLAB का कोडिंग मैथमेटिक्स में करके देखेंगे, उसको चलाएंगे बार बार, then we can understand how it is applicable. So at this introductory lecture, what is expected from you? Yes, we have one generalized technique which targets the number of harmonics, which target the harmonic, specific harmonic, and we can eliminate that harmonic by using chops. We are chopping, we are notching the output AC voltage waveform, and these chops are created by specific angles, at specific angles. And my dear friends, these angles are decided by using these formulae. These formulae are related with the Fourier series. This is the information you must understand. Details, if you understand, it is okay. So just for detailing, this is not means you are not expected to understand this. These are Fourier series representation. Okay, and this is value of an and bn. N is equal to 0 if it is n is even. ऑड होगा तो ही ये वैल्यू होगा 4/n पाएगा, right? And then angle is from 0 to pi by 2. Any angles are pi by 2 means 90. And then these expressions are like this: f1, f2, up to fn, n number of explanations. And for that, uh, these are the different means so many chops, so many equations we have to deal with. So I haven't made it. I am not giving further details of how to calculate. Then, if we solve this particular um, equations, so you also know the simple nonlinear equations solution. If you have two unknowns, then you have two equations like this: four unknowns, four equations; three unknowns, three equations. What are unknowns? Angles. कितने एंगल चाहिए भैया? अल्फा वन, अल्फा टू, अल्फा थ्री, तीन एंगल चाहिए। तीन क्यों चाहिए? तीन हार्मोनिक्स रिमूव करना है, इसलिए तीन चाहिए। तो ये एंगल्स कैसे आएंगे? ये फॉर्मूल तीन इक्वेशंस है, तीन अननोन्स है, सॉल्व करो, यू विल गेट इट। ये बेसिक कंसेप्ट है मैथमेटिक्स का, आपको सबको पता होगा, राइट? Number of equations and number of unknowns, and get the angles. So my dear friends, two angles you need, only go for two equations. You want to go for three angles, you go for three equations. Nine angles, nine equations. So but more the number of angles, more the number of equations, solution will be tricky. But nowadays we are having tools like MATLAB and all those things. So with the help of coding, it is easy to now. It is easy also. Little bit complex to understand, but for execution it is easy. Select the number of angles, then automatically you will select the number of equations, and you will select number of unknowns. Those unknowns will be available to you. Basic is this one, Fourier representation. So in this way, angles are also selected and so angles are also decided. I hope you understood it. And just we are at the fag end of this one. And uh, this is also explained, already explained to you. Please go through this presentation PPT once again. You will understand basics, and ultimately, ultimately, we are interested in the final how the questions are asked. So we have to go for this. Answer should be weightage will be most maximum 7 marks. So two three waveforms, at least two waveforms you must draw for explanation. Then you must go for Fourier series representation for explanation, and then simple explanations of that is given here: m number of chops, m minus 1 of number of harmonics are eliminated. This much is required. Some extra information you can give. This is extra. This is not required. This is not required. This is extra information, right? This formula you can write k1 into n plus minus k2, basic formula. So this much is explained, required, not all, for gaining 7 marks, right? This is important. ये इक्वेशन इम्पोर्टेंट है, और ये डायग्राम इम्पोर्टेंट है, राइट? ये और फिर अगर चाहो तो ये ड्रॉ कर लो। ये थोड़ा डिफिकल्ट है ड्रॉ करने के लिए, यू मे गो फॉर दिस डायग्राम, सिंपल डायग्राम, राइट? Then you may go for this formulae, right? Given on this page, particularly two formulas only, some explanation, and then you go for explanation which is given on this particular slide number 4 5. This is done. I hope, my dear friends, I have given my best to explain this with the pre-recorded video. Of course, we will have some discussions in next online lecture, and I'll ask you some questions. You ask me some doubts, so that conversation will happen, and then we can say that our topic is covered thoroughly, right? Um, okay, so I declare this topic is over, and please go through this presentation uh, with your own pace of understanding. All the best. Thank you very much, and I will definitely wait for your questions. and please let me know if you are having any doubts or problems, difficulties regarding this particular topic. And we are almost through with unit number 2 also, and we will start unit number 3, 4, 5, 3 or 5 any time with the next lecture. Thank you very much, my dear friends. Thank you very much.